morning, Manandal. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in today's lecture, we are going to learn about one of the topic in electromagnetic waves and transmission lines as Coulomb's law and followed by electric field intensity. The lectures which have covered the topics, theory classes and all already we have been discussed in the previous one. Now we are going to concentrate on problems related to this Coulomb's law and electric field intensity. Right? So the first point problem is on Coulomb's law. Now from this Coulomb's law is deals with the equation called force, electric force, and generally it is measured in newtons. And from the given problem, first of all, we are going to identify what is the given data. Now, from that, we'll be evaluating what is the respective terms we are going to solve. So, first problem is on Coulomb's law. Now, from this, we are going to evaluate along with the force equation, electric field intensity also. So, these Coulomb's law and electric field intensity concepts are covered in electrostatics. Now here, the given one is given by here. A point charges 1 millicoulomb and minus 2 millicoulombs are located at 3, 2, minus 1 and minus 1, minus 1, 4 respectively. Then calculate the electric force on a 10 nanocoulombs charge located at 0, 3, 1 and the electric field intensity at that point. Means first of all we need to calculate the electric force, means F value we need to find on a 10 nanocoulombs charge, means the charge which exerts on this particular one is denoted with Q and it is located at the particular point 0, 3, 1 means the point is given as R, and we need to find along with the electric force, electric field intensity also. So this electric field intensity is given by here the notation as E. Then from this the given data we are going to evaluate the two equations for electric force which is represented with F and the next one is electric field intensity as E. Right? So to find electric force and electric field intensity, so first of all we have to identify what actually given data. Now from this, see 2 point charges means let it be I am considering the first point charge as Q1, 1 millicoulomb and second one is represented with Q2 as minus 2 millicoulombs. And these two charges are respectively located at position vectors, means R1 and R2, or given as R1 is a vector which is represented as here 3, 2, minus 1 and R2 is minus 1, 4 respectively. So here we have given 2 point charges Q1 and Q2 along with the position vectors R1 and R2. Along with these four, we will have another one is a charge which exerts on these two particular charges Q1 and Q2 as Q. Right? So from this Q, what is the distance this from Q to Q1 and Q2 we are going to estimate the positions, and from this R1 and R2 are respectively given as the position vectors R1 and R2, and where the Q is exerts on, means at this particular point charge Q, the point is given as 0, 3, 1. So from this, first of all, Q1 equal to 1 millicoulombs, means milli representation, we have to write it as 1 into 10 power minus 3 coulombs, and for Q2 equal to minus 2 millicoulombs, nothing but minus 2 into 10 power minus 3 coulombs. And along with the position vectors means R1, vectors we need to represent in two different ways. One is along with the only magnitude and one more is along with the magnitudes we need to write unit vectors also. So suppose if R1 is given as like this 3, 2, minus 1. So magnitudes of these three means generally we are assuming the first type of coordinate system as Cartesian coordinate system. In that vectors are represented with the variables are represented with x comma y comma z, and the unit vectors means ax comma ay comma az. So this is the way we have to write the one vector form as r1 equal to 3 comma 2 comma minus 1, or if you're going to elaborate this one with the vector form along with the magnitudes means 3 into ax plus 2 into ay minus az. Okay, and similarly r2 also. R2 is also a vector and it is given as minus 1, 4, means along with the magnitudes we have only minus 1, 4, and if you're going to elaborately represent this one with along with the unit vectors means minus 1 into ax, then plus minus 1 into ay, then plus 4 into az, which is equal to minus ax minus ay plus 4 az is the R2 value. And along with that, here the two charge which exerts on the particular force B is given as Q, and it is represented with 10 nanocoulombs. Means 10 nanocoulombs can be written as, where nano stands for, it is represented with 10 power minus 9 coulombs, right? Charge. And this particular charge is located at R, means that is given as 0, 3, 1, right? So in order to write these two, see, R means along with the magnitudes, we need to represent the vector forms also, means 0 into ax plus 3 into ay plus 1 into az, or 3ay plus az is given as R, right? So now we have here 2 point charges Q1 and Q2 along with the position vectors as R1 and R2, and the charge which exerts on these two particular charges Q1 and Q2 is given by Q, and that is 10 nanocoulombs. And this 10 nanocoulombs is located at R, that is 0, 3, 1. So from this given data, we are going to find the electric force, right? So in general, the Coulomb's law is given as F is equal to, F is also a vector, that's why we need to write F over bar. Now to represent it as vector, F bar equal to Q into Q1 by 4 pi epsilon naught into R minus R1 by modulus of R minus R1 whole cube plus Q2 by 4 pi epsilon naught into R minus R2 whole cube and R minus R2, right? Or it can write approximately as Q by 4 pi epsilon naught as common, then summation of K equal to 1, 2. Why? Because that charges are given 2 charges, hence K value is ranging from 1 to 2, and it is represented by Qk into R minus Rk by R minus Rk whole cube, right? So in general, the force equation, or according to the Coulomb's law, it is given as F is equal to Q by 4 pi epsilon naught sigma K equal to 1 to n, that is Qk into R minus Rk by modulus of R minus Rk whole cube, right? So for here we have 2 charges, means we are representing the K value as ranging from 1, 2. Hence F is equal to, this is the general equation. Now approximate equation for 2, and from this we are going to write elaborately Q1, R1, Q2, R2 and Q along with R, right? So in order to find this electric force, first we need to find the vector positions. So first R minus R1 equal to, so what is the value here given? R is 0, 3, 1 and R1 is 3, 2, minus 1, right? So R value 0, 3, 1 minus 3, 2, minus 1. This is R, this is R, and here it is R1. 0, 3, 1, 0, 3, 1 and 3, 2, minus 1, right? So from this, if you want to calculate 0, 3, 1 minus 3, 2, 1, 3, 2, minus 1. Now, the distance between these two can be calculated x2 minus x1 plus y2 minus y1 plus z2 minus z1 into ax, ay, az respectively. So from this, we are going to write 0 minus 3 into ax plus 3 minus 2 into ay plus 1 minus of minus 1 into az. Okay, then which is equal to minus 3ax plus 3 minus 2 is 1 and 1 into ay becomes ay, then plus 1 minus of minus 1. This minus of minus becomes plus 1 plus 1 becomes 2, then 2 into az is given as r minus r1. Right? Then from this we are going to find the magnitude modulus of r minus r1 means why? Because in the denominator we'll have modulus of r minus r1. That's why we'll find out the magnitude of the given r minus r1. So here now to find the magnitude we'll consider only magnitudes of the given vector, that is minus 3 whole square plus 1 square plus 2 square, which is equal to 3 square becomes 9, 9 plus 1 is 10, 10 plus 4 is becomes 14. That is root 14 is the modulus of r minus r1. Right? Now from this r minus r2. In the next equation we'll have another vector as r minus r2. Right? So to find this r minus r2, see r values already we know that 0, 3, 1 minus of minus 1 minus 1 4 is given as for the value of r2 from the given minus 1 minus 1 4. Right? So to find this the distance between these two, which is equal to, how are you going to find? 0 minus of minus 1 into ax, then plus 3 minus of minus 1 means 3 minus of minus 1 into ay plus 1 minus of 4 into az, which is equal to, how are you going to calculate? Minus of minus becomes plus into ax, then plus 3 minus of minus 1 becomes plus 3 plus 1 as 4 into ay, then 1 minus 4 as minus 3, then into az. Right? So this is the value of r minus r2. Right? From this r minus r2, if you find magnitude means modulus of r minus r2 equal to root over 1 plus 4 square as 16 plus 3 square as 9, which is equal to root 26. Right? Now substitute r minus r1 by this minus 3x plus ay plus 2az and r minus r2 by ax plus 4ay minus 3az and r minus magnitudes of r minus r1 and r minus r2 are respectively given as root 14 and root 26. Now substitute all this in the Coulomb's force equation. Right? Now that is given by F is equal to, so Q, what is that Q value? 10 nanofarads, that is 10 into 10 power minus 9 into, and the Q1 means the first two point charges are given as Q and Q1. Those are, see here, Q1 equal to 1 millicoulomb and Q2 equal to minus 2 millicoulombs. Right? So substitute in place of Q1 by 1 millicoulomb, 1 into 10 power minus 3 by 4 pi epsilon naught. In order to write this 4 pi epsilon naught, 4 pi into epsilon naught value, as we know that 8.854 into 10 power minus 12 farad per meter. Now 4 pi into 8.854 into 10 power minus 12, or instead of writing epsilon naught by this 8.854 into 10 power minus 12, if we write 4 pi into 36 by pi, 4 pi. This epsilon naught value by 36 by, or instead of considering only epsilon naught value as 8.854 into 10 power minus 12 and 1 by 4 pi epsilon naught value, if we find and if we substitute in place of epsilon naught by this complete thing, then its value is approximately equal to 10 power 9 into 10 power 9. Right? So substitute in place of 1 by 4 pi epsilon naught by this value 9 into, hence 9 into 10 power 9 into. Right? So this is the value for the first value is Q and the next is given as Q1, and this is completely related to 1 by 4 pi epsilon naught value. This value is 36 pi by 36 by 4 pi. So if you simplify like that, then 1 by 4 pi epsilon naught value is 9 into 10 power 9. So all these are substituted into the same equation which we have got from the Coulomb's law, that is q1 by 4 pi epsilon naught already we have substituted, and in place of r1, r minus r1 means what is that we have got? Minus 3ax plus ay plus 2az by, and modulus of r minus r1 value we have got here, it as root 14 means r minus r1 equal to root of 14, then modulus of r minus r1 whole cube means 14 root 14 we have considered further. So 14 root 14, and this is the value, then plus q into, again q means 10 into 10 power minus 9 into q2 is minus 2 millicoulombs, that is 10 power minus 2 into 10 power minus 3 by, and this 4 pi epsilon naught value is 9 into 10 power 9 into, right? So here what is this one? This is q and this is q2 and this is 1 by 4 pi epsilon naught value. Okay, then into, and r minus r2. r minus r2 is given as ax plus 4ay minus 3az. 3az. Okay, so by, and in the denominator we are going to write r minus r2 whole cube. So modulus of r minus r2 means its value is root 26. Now if we substitute r minus r2 whole cube means 26 root 26, right? So upon simplifying the complete equation, see the complete equation we are going to get here, see 10 power minus 9 and this 10 power 9 gets cancelled, and 10 into 10 power minus 3, and already we have left out here 9 and 90 into 10 power minus 3 into, okay, so minus 3ax plus ay plus 2az by 14 root 14, then minus, why? Because here see 10 power minus 9 and 10 power plus 9 gets cancelled, then 10 into 10 power minus means 9 into 10 becomes, so 90 here, and if you multiply this minus 2 with the plus is minus, then 2 into 20, 20 into 9 means 180, 9 to 0 18, 18 into 10 is 180 into 10 power minus 3 into, and ax plus 4ay minus 3az by 26 root 26. Okay, so equal to, f equal to, so if you simplify, see here 90 into 10 power minus 3 by 14 root 14, and we'll have some magnitude, and here 180 into 10 power minus 3 by 26 into root 26. If you simplify this one, we are going to get one more value. Now in between two, we'll be having the common terms as some factors, something in 10 power minus 3, and in the numerator part we have ax coefficient as here minus 3, and here it will be 1, and here is 1, and here it will be 4, and here it is 2, and here it will be minus 3. Now if we simplify the entire equation, then f is equal to something into ax plus something into ay plus something into az newtons are to be obtained, right? So that something value is to be obtained. If you simplify the entire equation, we are going to get minus 650.7 ax minus 381.7 ay plus 750.6 az into 10 power minus 3 is there. For that, we are going to write it as milli, and the units for force is given as newtons. Hence, F is equal to minus 650.7 AX minus 381.7 AY plus 750.6 AZ millinewtons are to be obtained. Okay. Now, after finding this electric force, we need to find electric field intensity. So, to find this electric field intensity, the relation between F and E in electrostatic field equations are given by, according to the definition of electric field intensity, E equal to F by Q. Okay, E equal to F by Q. Now from this we have been evaluated the value of F, and it is multiplied with electric field E is multiplied with a point charge Q. So see here, F by Q, or from this E equal to F by Q. So to find this electric field intensity E, then E equal to F by Q. So the total equation is given as here, minus 650.7 AX minus 381.7 AY plus 750.6 AZ whole into 10 power minus 3 by, and E equal to this one, right? So by Q value is given as here 10 nanocoulombs, 10 power minus 9, right? So which is equal to, see, if you simplify the entire equation, and if you are going to calculate 650.7, 381.7, 750.6 like that, you're going to express this one in terms of kilo, or here 10 into 10 power minus 9. This becomes 10 power minus, in the denominator part 10 power minus 8, and in the numerator we'll be having 10 power minus 3. So 10 power minus 3 means 10 power minus 3 into 10 power, in the denominator it will be 10 power minus 8. It will become numerator term means then it is 10 power 5. Then all should be multiplied with hundreds. Then it is given by here E equal to minus 650.7 AX minus 381.7 AY plus 750.6 AZ kilovolt per meter. Right? Generally, the electric field intensity E is measured in volts per meter, and into 10 cube is the there to be obtained. Now in order to express that one, 10 cube, we have considered that in terms of kilo. Right? So previously that was, I think, 6.507 AX, then 3.817 AY plus 7.506 AZ millinewtons are to be obtained as the value of F. And from this, we have been evaluated electric field intensity as E equal to minus 650.7 AX minus 381.7 AY plus 750.6 AZ kilovolt per meter. Right? So first of all, how we have been evaluated? First of all, given data, will be identifying here what actually given data. Now from this, what is the formula we need to apply to find the electric force and the electric field intensity? So from that, first we will be calculating electric force equation from Coulomb's law. Then after that, we have to substitute in the place of that electric force, and the charge which exerts on the respective two charges, and based upon that we'll be calculating the electric field intensity, or it is also called as electric field strength. Okay. Then, so second problem, the similar problem which we have already discussed in the previous case, it has, see, point charges 5 nanocoulombs and minus 2 nanocoulombs are located at 2, 0, 4 and minus 3, 0, 5 respectively. Means 2 point charges 5 nanocoulombs. The value of Q1 is 5 nanocoulombs, and which is equal to 5 into 10 power minus 9 coulombs. Nano representation, we have to write it as 10 power minus 9 coulombs. And for this thing, minus 2 nanocoulombs means its value is about, for Q2 equal to minus 2 into 10 power minus 9 coulombs. Nano representation, we are using 10 power minus 9 times. And these two are respectively located at first point as R1 and the next point as R2. Right? So R1 equal to 2, 0, 4 and R2 equal to minus 3, 0, 5. Right? So if you want to express this one in terms of completely along with the magnitudes and the vector form, R1 can be written as 2AX plus 0 into AY plus 4 into AZ. Means 2AX plus 4AZ is the value of R1. Similarly, minus 3, 0, 5 is the value for R2, means that we can write it as minus 3AX plus 5AZ. And we didn't have any Y value. Why? Because its magnitude is given as 0. Right? So first of all, from the given, we have to identify Q1 and Q2 values are represented in the nanos, and R1 and R2 are given as like this. Now from this, what we are going to find out. So determine the force on a 1 nanocoulomb point charge located at 1, minus 3, 7 and find the electric field E at this particular, that is 1, minus 3, 7. Means the point charge which exerts on the two are given as 1 nanocoulomb, means Q is given as 1 nanocoulomb, 1 into 10 power minus 9 coulombs, and located at R is given as 1 AX minus 3 AY plus 7 AZ. Right? So here R1 and R2 along with R3 are representing 3 vectors, and we need to find first electric force. From that, at that particular point only, you're going to evaluate electric field intensity E. Right? So to find this first, as we know that the formula for the electric force from the Coulomb's law is given by Q by 4 pi epsilon naught summation of K equal to 1, 2 Qk into R minus Rk by modulus of R minus Rk whole cube. And upon expansion of this one, Q by 4 pi epsilon naught into, so Q1 into R minus R1 by modulus of R minus R1 whole cube plus Q2 into R minus R2 by modulus of R minus R2 whole cube. Okay, so now from this, if you're substituting all the values in this electric force equation, then F equal to, so what is that value is given for Q is nothing but 1 nanocoulombs. 1 into 10 power minus 9 by 4 pi epsilon naught means 4 pi into 8.854 into 10 power minus 12. Or if you want to substitute in place of the total thing by, okay, then 1 into 10 power minus 9 by 4 pi into 8.854 into 10 power minus 12. And in place of Q1, if we substitute 5 nanocoulombs, 5 into 10 power minus 9 into, okay, so Q1 value is given as 5 nanocoulombs, 5 into 10 power minus 9. R value is 1 minus 3, 7 minus R1 is 2, 0, 4 by 1 minus 3, 7 minus 2, 0, 4 magnitude. Then plus Q2 is, that is minus 2 nanocoulombs, minus 2 into 10 power minus 9 into R minus R2. R value is 1, minus 3, 7 minus, then R2 is here minus 3, 0, 5 by, in the denominator, R minus R2 whole cube is there, then R means 1, minus 3, 7 minus 3, 0, 5 is its magnitude. Here also whole cube is there, right? So in order to simplify the total equation, we just consider here first F equal to 1 into 10 power minus 9 into, so 1 by 4 pi epsilon naught value, 1 by 4 pi into 8.854 into 10 power minus 9. If you evaluate this, the total thing, you're going to get 9 into 10 power 9 meters per farad is the value for 1 by 4 pi epsilon naught. Now, in place of this total denominator term, if you substitute 9 into 10 power 9 into, so 5 into 10 power 9 means in between 2, we just consider the two common terms as 10 power minus 9 is the common between 2. Why? Because Q1 and Q2 are given as in terms of nano. Hence, this if we take this 10 power minus 9 into out of this equation, then it becomes, see, 5 into, first R value is given as 1, minus 3, 7 and R1 is 2, 0, 4. If you subtract 1 minus 3, 7 to 2, 0, 4, then it becomes 1 minus 2 means minus 1, minus 3, 0 means minus 3, then 7 minus 4 is 3. By, in the denominator, we find its magnitude 1 minus 3, 7, minus 2, comma 0, comma 4, then it becomes minus 1, minus 3, minus 3, then 1 square becomes 1, 3 square is 9, and here also 9, 9 plus 9 is 18, and 1 is 19, means in the denominator we are going to have 19 root 19. Okay, then, so here, nano 2, see, charge 2, that is Q2, is expressed in terms of nano. Hence it is minus 2 nano coulombs. So that's why in the second term we are going to get here negative term. Then minus 2 into 1 minus 3, already negative is there, we are subtracting, hence minus of minus becomes plus, 1 plus 3 becomes 4, and minus 3 comma and 7 minus 5 is 2. By, in the denominator, see, 1 minus 3, 7 minus 3, 0, 5, means 1 minus of minus 3 becomes 4, 4 square as 16, then 9 square as 3 square as 9, so 16 plus 9 plus 4, so 16 plus 4 is 20, 20 plus 9, 29, means 29 root 29 is to be obtained in the denominator, right? So if you simplify further, then f equal to, so f equal to, see, 10 power minus 9 and this 10 power minus 9 gets cancelled, then 9 into 10 power 9 is left out, 10 power 9 into, so 5 minus 5 minus 15 plus 15 by 19 root 19 minus 2 into, means 2 4s are 8, comma minus 6 comma 4 by 29 root 29 is to be obtained. If you evaluate the complete equation, means here ax value is minus 5 and here it will be minus 8, and here ay value is minus 15, here it will be minus 6, and az is here 15 and az is here 4, and if you are going to evaluate 9 into 10 power 9 in the first term as in the denominator 19 root 19 and 9 into 10 power 9 by 29 root 29, you are going to get all the magnitudes in terms of ax, ay, az. Now 10 power 9 is left out here. So from this we will be getting the value, see, 10 power, this 10 power minus 9 and this gets cancelled, 9 into 10 power minus 9 is left out. So if you multiply this 9 into the entire thing, then we are going to get the value for the electric force is to be obtained as minus 1.004 ax minus 1.284 ay plus 1.4 az nano newtons. So total into 10 power minus 9 is to be left out. So for the 10 power minus 9, we will be representing it as nano. Hence, my electric force F is equal to then minus 1.004 ax minus 1.284 ay plus 1.4 az nano newtons. Right? So that is to be obtained for electric force. Now from this electric force, we are going to evaluate electric field intensity. So to calculate this electric field intensity, E equal to, what is the formula? F by Q. So F value is to be obtained as here minus 1.004 ax minus 1.004 ax plus minus 1.284 ay minus 1.284 ay plus 1.4 az total into 10 power minus 9 newtons by 1.4 az. That is the value of electric force equation to be obtained from Coulomb's law. So minus 1.004 ax minus 1.284 ay plus 1.4 az nano newtons. Now find the electric field E at that particular point only. So that particular point is located at 1 comma minus 3 comma 7 itself, right? So from that Q. So that Q value is given as electric force equation. Q is to be obtained as 1 nanocoulombs. 1 into 10 power minus 9. So this 10 power minus 9 and this 10 power minus 9 gets cancelled. Then E equal to minus 1.004 ax minus 1.284 ay plus 1.4 az volts per meter. In general, according to this formula, E is measured in force is generally measured in newtons per charge can be measured in coulombs. So according to the definition, E is to be measured in newtons per coulombs, or from the fundamental one, it is given as volts per meter. Right? So electric field intensity E is to be obtained as E equal to minus 1.004 AX minus 1.284 AY plus 1.4 AZ volts per meter. Right? Or sometimes it is measured in newtons per coulomb also. Right? So this is the way. If 2-point charges are given and the charge which exerts on a particular point charge Q and it is located at a certain distance, then we need to find electric force along with electric field intensity. Means fundamentally we have to use according to the Coulomb's law. Right? From the Coulomb's law, we'll be calculating electric force, and from that electric force, we are going to evaluate electric field intensity. Now, another problem. So, the finer sheet, that is sheet, means we have to consider it as plane wise. Plane wise means we'll be considering two direction elements x, y, z. Suppose if here in 3D view, if my x is located here and y is here, z is y, means if you consider xy plane, z component is constant. If you are considering yz plane, x component be the constant, and if you are considering xz, y component be the constant. Depending upon that, means if the finite sheet means it is supposed to occupy two directions. Right? So that is given as here. The finite sheet 0 less than or less than x less than 1 and 0 less than y less than 1 means which plane is given? XY plane is given. So XY plane is given on the z equal to 0 plane, means z equal to 0 plane is represents, otherwise it is XY plane also. Right? So the finite sheet 0 less than x less than 1, 0 less than y less than 1 on the z equal to 0 plane has a charge density. So finite sheet we have considered. That's why throughout the sheet the charge is uniformly distributed. Hence its density is given as rho s. Surface charge density, which is equal to xy into x square plus y square plus 25 whole power 3 by 2 nano coulomb per meter square. Generally, this electric charge is measured in coulombs, and per density means it occupying some area. Hence, it is measured in nano coulomb per meter square. Generally, the formula is coulomb per meter square, and it should be given in terms of nanos. Now, from the given, find the total charge on the sheet and the electric field at that particular this 005, and the force experienced by a 1 millicoulomb charge located at 005. Right? So from the given, first xy plane is given, and along with that the charge density rho s is given. So as we know that for a continuous charge distributions in the electric fields, those are line charge density rho l, surface charge density as rho s, and volume charge density as rho v. Right? So now to calculate rho l, rho s, rho v, now here we are assuming it as per rho s. So charge q is given as, means q in terms of rho s means formula is given by q equal to integral s rho s into ds. See, rho s into ds. Rho s is given by here xy into the total thing, and ds, the formula for ds is surface. If you are considering 2 times, we need to integrate. And 2 times means what are the two variables you are going to consider? Means x and y. Hence, x is equal to 0 to 1, y equal to 0 to 1. The plane is given, that xy plane is given. So, x equal to 0 to 1, y equal to 0 to 1, and rho s means xy into x square plus y square plus 25 whole power 3 by 2 into dx. ds, the formula for ds means here the variables are given as x and y, hence ds formula is given by dx into dy. Right? So if you're going to evaluate this one, see here integral y equal to 0 to 1, then y into x square plus y square plus 25 whole power 3 by 2 and collectively from this x and this one we'll be writing it as dy x into dx. Okay, why? Because in order to integrate this one and see integral x equal to 0 to 1. Now to integrate this one, see x into dx. So already in the extra term is added, that is x square power 3 by 2, and here x is also there. So integration of uv, if you consider, there is a lengthy procedure in order to calculate, in order to simplify the total equation. Hence, we are going to use one simple equation called C 1 by 2 into d rho square can be written as 2 rho d rho by 2. See, d rho whole square. So we are differentiating this one with respect to rho square, hence it will be 2 rho d rho. And 2 and this 2 gets cancelled. What is that value? Rho into d rho is to be obtained. Now in place of rho d rho, what we have here? X into dx. Now what is the formula for that? Half into dx square. Right? So from that we will be calculating, then q equal to 1 by 2 integral y equal to 0 to 1 integral x is equal to 0 to 1 y into x square plus y square plus 25 whole power 3 by 2 into this x dx can be written as half, already we have written, that is dx square. So dx square is there, hence we are integrating this one with respect to 1 by 2, then integral y equal to 0 to 1, then y dy into means dx square. So integration of x is becomes x square by 2, hence it becomes x square plus y square plus 25 whole power 3 by 2 plus 1 by 3 by 2 plus 1. And we are substituting limits as 0 to 1. So which is equal to 1 by 2 into, in the denominator 3 by 2 plus 1 means that will be 3 by 2 plus 1 becomes 3 plus 2 means 5 by 2. And if you are considering it as 2 by 5. Why? Because this 5 by 2 is there in the denominator. If you take it into numerator, then it becomes 2 by 5 into, then y dy integral 0 to 1. Then if you substitute x square by 1 first, 1 plus 25 becomes y square plus 26, right? Whole power 5 by 2 plus, right? And again if you substitute the lower limit as 0 here, then y square plus 25 whole power 5 by 2 into y dy, right? So this 2 gets cancelled, 1 by 5 into, again y dy. Y dy means how you are going to write? Again half into dy square, that is 1 by 2. Then again if you are integrating this one, y square plus 26 whole power 7 by 2 by 7 by 2 plus y square plus 25 whole power 7 by 2 by 7 by 2. And if you are substituting limits as 0 to 1, then it becomes like this. So here 1 by 5 into 1 by 2 becomes 1 by 10. Then 2 by 7 is to be left out into. So if you are substituting lower and upper limits as 0 and 1, means first if you substitute 1 means 1 plus 26 becomes 27 whole power 7 by 2 plus, if you are substituting lower limit means, and here also 26 whole power 7 by 2 plus lower limit case 26 whole power 7 by 2 minus and minus 25 whole power 7 by 2, right? So these two gets cancelled, 1 by 35 into, and if you simplify the total equation, we are going to get the Q value equal to 33.15 nano coulombs. Why? Because the given rho s is in terms of nano. Into total equation becomes 10 power minus 9 is there. For that, Q equal to 33.15 nano coulombs are to be obtained. Right? Similarly, Q is to be obtained. Now from that Q, we are going to calculate electric field intensity and F value. So Q value is equal to 33.15 nanocoulombs are obtained. Then from this E equal to F by Q. From this, we want to calculate F value, that is multiplied with EQ. So first we are going to evaluate this thing E, and E in terms of the charge density formula means E equal to integral S rho S ds by 4 pi epsilon naught into R minus or R square, modulus of R whole square, right? So integral S means x is equal to 0 to 1, y equal to 0 to 1. Why? Because the sheet is given for xy plane, x equal to 0 to 1, y equal to 0 to 1. If you substitute rho s by again xy into x square plus y square plus 25 whole power 3 by 2 by 4 pi epsilon naught means 8.854 into 10 power minus 12 into r square. R square value is given as, that is x comma 0 comma 0 comma 5 means r value, r square value becomes 25, right? So we simplify that one, and the formula for ds is given by again dx into dy. So if you simplify whatever we have considered in the previous case, how you are going to evaluate the same thing. If you evaluate that one, the electric field intensity E is to be obtained as minus 1.5 comma minus 1.5 comma 11.25 volts per meter. Generally, the electric field intensity E is to be expressed in terms of vector form, means 1.5 ax minus 1.5 ay plus 11.25 az volts per meter. Now from this E, we will be calculating F, means E is equal to F by Q, or from this F equal to E into Q. So E value is the total thing into Q value is given as, that is minus 1 millicoulombs. Now if we substitute minus 1 milli and 1.5 AX plus 1.5 AY minus 11.525 AZ millinewtons are to be obtained. This is the way we have been calculated. For a finite sheet of charge is given case, how the total charge is to be evaluated. From that, the electric field intensity, then after that, the force which is experienced on that particular charge is to be evaluated, right? So this is the way problems on Coulomb's law and electric field intensity, then some of the applications related to this electric field intensity we calculated. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.